Okay, we'll talk about tuples. Now, what is tuple? Now, before that, we'll revisit list. So what we said, list is linear, okay, ordered, mutable collection, right? So each of these has a meaning. Linear, one dimensional, right? We cannot store two-dimensional data. One dimensional. Ordered, that means there is an order to the value that we add. Okay, that means when you add first element, it's called first element because it has index 0. When you add second element, it's called second element because it has index 1. So there is a inbuilt order that is created when you start adding data to list. Okay. Now, second or third property is that it's mutable, right? We discussed that you can easily change, right? Values, you can mutate, you can edit the values, right? You can easily say, okay, change the first value to 5, right? You can easily change first value to 5. So, so it's called mutable in that respect. Now, collection means more than one values, right? Now, if I take same definition for tuple, okay, it is linear, it is ordered, but it is immutable. Okay, that means you can't change the value that you add in tuple. That's the only difference between list and tuple. Okay. Okay. How do you declare tuple? We used simple square bracket, right? We use square bracket for list. Tuple we use simple bracket. Okay. Using simple bracket we use now. When do we use simple bracket other than this? We use simple bracket other than this for functions, correct? Functions, yes. And second thing is we use this for mathematical operation, right? When you want to, let's say you have addition and multiplication together, but you want to perform addition before multiplication, right? BODMAS rule, first multiplication will happen, then addition will happen. But if you want to perform addition before multiplication, right? So you will put that in the bracket, indicating that bracket takes higher precedence over multiplication also, isn't it? So, and this is third usage. Now, for functions, it's easy. You put, if I put a bracket like this, that means it's a function. Okay. But if you put something like this, it can be either your mathematical operation or it could be your tuple. But you would not put blank data in a bracket, right? So if you do not put anything blank here, okay, it means it's tuple. So if I say print type of T1, okay, just move it from, okay, or let it be here. Let's select IES. Okay, so you get tuple. Now, but if I add one member to it, okay, mathematics will also have one member. Okay, so it will treat as integer, not as a tuple. Okay, so you can declare a blank tuple without any problem. But if your tuple has one member, if your tuple has one member, then you add comma. Then you add comma. Okay, comma would indicate, because mathematical operation will not have comma. Okay, so now when you say comma, it will not treat as mathematical operator, but as a tuple. So now when you run T1, you get tuple. Okay, it should have no value at all or at least one comma. But when you have multiple values, then it's not a problem. When you have multiple values, then you'd give like 5, 6, comma 7, it's fine. So only have to keep in mind that when you have only one value to pass in tuple, you have to put extra comma. Simple. Okay, you have only one value to pass in tuple, that's when you give comma. Otherwise, it's all fine. Right? So this is how you declare tuple. Okay, and accessing is very similar to string or list, so I'm not going to talk about it here, right? it has both forward and backward indexing, 0 to n minus 1 forward, minus 1 to minus n backward. Okay. Now, since it is immutable, our life is easy because when you say T1 dot, you have only count and index. Okay. You do not have append, insert, okay, or remove or pop, because those are for changing the structure of tuple. Okay. But you don't have all those things. Count will tell you how many occurrences of X is there. So if I say T1 count 5, how many 5s are there in the tuple? And then index will tell you the index position of X. So if I say 5, you get index 0. Okay, count 1, index 0, right? Same thing we have in list also. Okay, so when you are actually, when you don't want data to be changed even accidentally, okay, you should declare as tuple. So when you say tuple, then it will not allow it to have any of those edit to be performed there, right? So it will not allow edit to happen. So even by mistake, nobody can change it. Okay, so if you do not want data to get changed, you should use tuple. Best part is you can convert tuple to list and list to tuple without any problem, because both are linear ordered, one dimension, right? So you can easily convert list to tuple. Okay, so you can say T1 equal to list of T1. And now when you say T1 dot, you see all the properties of list is available. So if you want to add something to tuple, you have to take extra step of converting into list. That means you are consciously trying to edit it. Okay, it's like a lock, right? If you have the key, you can enter into the lock, but if you enter the house, but if you do not have, you can't enter. So this is like, like key, right? If you want to edit it, you're writing this consciously to make it, edit it. Advantage of tuple is that it is fast. So if you have to read it like for loop, okay, if you have to use for loop, it is better to use tuple. Tuple will go through the list faster. Go through the list, no, go through the data, right? Go through the members. That's what I mean, right? Not list as in Python list. Okay, tuple, you can go, the accessing is faster, right? So that's why generally people prefer tuple for read operation, and of course no option, but to use list for write or edit option. Okay, you can convert it back using tuple. So now you're done. Let's say you're done adding. So let me add something to it. I'll say T1 dot append 8. Okay, 8. And now I'll convert it back to tuple. So tuple T1. And now you say T1 dot, you see only count and index is available. Okay. So one concept that we can talk about here is called packing unpacking. Okay. So in a way, this is like a concept of packing. You are assigning multiple values to one variable. Okay. You're assigning multiple values to one variable. So it's like packing, you say that it's packing. Okay. Multiple values to one variable. You can unpack. Unpack means one variable to, or one value, okay, one tuple value to multiple individual variables. So now how many variables T1 has? T1 has 4 variables. So you can unpack using 4 variables, A, comma B, comma C, comma D equal to T1. Okay. Now you can say print A. Right? 5. Okay. So so what's the usage? Okay. Sometimes, when you are doing function, okay, or some kind of things, you want to return multiple values. So instead of returning multiple values, you can return as one single variable. You can return multiple values in Python, but okay, it's we return as one single value. And later, if you want to break into different variables, okay, and in machine learning, okay, when we are not going to do that in our course, but sometimes what happens is you get multiple values. You get different statistics that needs to be returned. So when you have different statistics that needs to be returned, okay, your variables you can assign to different variables, and then you can say, okay, A is Z score, B is P score, C is something, D is something, right? So you can break it into multiple parts, okay? Or you can also do T1 of 0, right? It is same as doing T1 of 0, right? Indexing. So both will be same, right? And thing is, number of variables that you give here has to be same as the number of members in T1. You cannot give one less or one more. If you give one more also, it's going to throw error. Okay, not enough values to unpack. Okay, it does not have enough values to do unpacking. We have only 4 and you're asking for 5, so I don't have enough values to unpack. If you give less, also you will get problem, too few values to, or too many values to unpack. Okay, you have too many values, but you have very less, values to handle it. Okay, so so that's why we need to give exactly 4 number of variables. Okay, the rest of the properties are same. You can do a for loop, as I said, very much like the list. You can do in, not in, right? So if I say print 6 in T1, right? So is 6 in T1? Yes, it is there in T1, right? If I say 16, 16 is not in T1. And same thing you can do in string and list also. That's what we are doing in for loop, right? So 16 is not in T1. Okay. You have, okay. So let's say you have 2 tuple. Okay. 2 comma 99. And let's say 1 comma 9. These are 2 tuples. Which one is greater? A is greater or B is greater? Let's say I put A equal to. And here I go and I say B equal to. Which is greater? A greater or B is greater?
A is greater.
B is greater? A is greater, right?
A is greater, I said.
A is greater, correct. Now, if I make this as 9, then
Like we can't say right, like both.
you can say, okay,
Like
here,
in 2 and 9, we'll say B is greater.
no. Here, B is greater because we always compare first member.
Yeah,
Okay,
then B is greater.
yes, that's what I'm saying. It is B is greater. Now, if both are same, okay, so let's say you have 99 comma 15, okay, and here you have 9 comma 99, and you have 2 here, okay. So what we do is, now we compare second member, okay. So when first member is same, we compare second member. Now second member A is greater, right? So when first is greater, so you don't compare rest of the values. You compare only one at a time. So first you compare first member. First member is 2. 2 same. So it is same. We can't say. So you have to go to next member. 99 and 9. 99 is greater. So now A becomes greater. Let's say I put 99 here. Then it goes to third member. Okay. In this case, again, the third is greater. Now let's say here I have only 2 members. Okay. Third member is not there, but this one has third member. So this is greater. Okay. So you compare each member. Okay. So in this case, A is again greater. But if I put 15 here, then all the values are same. Then you say A and B are equal. When all the members, they should have same number of values and it should be exactly same values. That's when we say they are equal. Otherwise, you will have, some relation. Either A will be greater or B will be greater. Okay, so we always compare from first member, then second member, then third member, so on. Okay. So yes, that's it about tuple. Tuple is more used, okay, than there's nothing anything about it because it's a immutable, right? You can't edit, you can't change the value, but you can read it. Okay. But if you have to do it, of course, you can convert into list and then you can use all the properties of list. Right? Okay. Any question before we move to next topic? Okay. Now, in this case, okay, in dictionary, it is non-linear. We call it non-linear. Okay. Or even if you can call it, but definitely not ordered. Okay. It is unordered non-linear collection. Non-linear because it is not straight line. Okay. Just like, list tuple. Okay. It is non-linear and it is unordered. So what does that mean? Okay. Unordered. Okay. It has its own key. We don't use index here. In dictionary, we don't use index. Dictionary has its own keys. So if I declare D1 equal to, you put curly bracket. Okay. And then you give key colon value. Okay. Comma. This is first value. Next. Okay. You can say key colon value. So whatever you write before colon is the key, and whatever you write after colon is value. So here it does not have its own index. It does not have its own index. We have to give the index. Okay. Sometimes, let's say you want to store marks of employee, right? Marks, not marks of employee, let's salary of employee or something of employee. So employee ID can be your key. Okay. Marks of student, roll number can be your key. Key is something that has to be unique. You can't have a duplicate key, right? If you have duplicate key, the last value that you add will be taken as the value. Okay, the first value you will not get. But values can be duplicated, isn't it? Two students can get same marks. Two employee can have same salary, but not the employee ID, not the roll number, right? So, okay, sometimes it is useful to use dictionary because you can give your own index. Now, if I give 0, 1, 2, 3, 4 index, so you have no control. You don't know what is whose data is in 0, whose data is in 1. But if you are using your own key, you know, okay, this is the roll number. So this roll number has this data, right? So dictionary also has its own advantages, and list also has its own advantages. You have to know which one to use, when to use, which one to use. That's it. Okay. So as I said, in dictionary, we have to give key and value. So I didn't tell you that, curly bracket is used to represent dictionary, right? So if I say D1 equal to curly bracket and I say print D1 or type of D1, okay? D1 of course will be empty. I say type of D1 and when you run it, one second. Okay. So see, it is class dictionary, right? Obviously it is dictionary. Okay. You can have values. That's what, okay, we'll do here because we don't want old data to confuse us. Okay, the dictionary, and you can add values. Okay, now if I say here, okay, print, okay, D1 off, 1. Okay, so key is used as index. So indexing is same. Here you don't have order. So you cannot say 1, 2, 5, right? You cannot say 1:5 because it does not have its order. But you can do 1 to 5, 1:5 in list and also in tuple, right? Not in dictionary. So when you run it, okay, you get D of 1 is hello. Now D of 2, 2 is a string, right? So I have to type as it is 2. So you get 999, right? So if you're adding values, you have to add like this. But sometimes you might want to add it like a you want to add it like on dynamic basis, right? Like using append. Now append is different because you're adding only value, isn't it? The key is already taken care automatically, right? In list, when we say append, okay, or even say insert, you are giving key, comma, value, right? Okay, but append, you're adding a value automatically. Here what happens is, since you do not have, since it has both key and value, you cannot add simply a value to dictionary, okay? So you can only add a dictionary to dictionary. Okay, so in list also we used extend. We used extend to add to a list. Here we have something called as update. Okay, so extend we use in list to add two lists together. Here update is used to add two dictionaries together. So dictionary can only get a dictionary value. So I can say T1 temporary 1 equal to true colon true colon say Sunday something, right? And then you say D1 dot update. Okay, and you say D1. Now you print D1. Right? So you get, right? What did you get? Do you see any difference?
Yes, I have seen the difference. Like true, it is printing 1, right?
Yes. So remember, true is 1 and false is 0. Okay. True is 1 and false is 0. So as I said, you cannot have duplicate values, right? You cannot have duplicate values, duplicate index. So in this case, it has become, you have already 1 here, and then you're adding true here. So true, okay, is converted into 1. So what happened? I told you, when you have same index, right, or same key, the latest value is added. Old value is lost. Okay, so if I make it 2 here, okay, then you can see you have all the 3 values. So you cannot have duplicate. So when you're using true and false, be careful. But you can use true and false. Okay, it accepts true and false. But when you're using it, be careful. 0 will go away if you have false, and 1 will go away if you have true. Okay. So this is about accessing. Okay. Now it has, you can get a list of, it has 3 methods like items, keys, and values. If you want to display only values, it'll give you list of values. If you want to display only keys, so you can use keys. And if you want to display both key and value, so it is list of tuple of key comma value. Okay, so let's see this. So if I say for, okay, you can print like this, but when you print it, let's see what happens. Print d1 dot items. Okay, so it will print in this format, dictionary items. Okay, dictionary items, and then you see this is your list, and each of these are tuple inside this, right? 2 comma hello, 2 comma 99, true comma Sunday. So you can display like this, but if you want to access each member, you put it like a for loop, right? So for I in D1 dot items, and you print I. So since we have said items, okay, is it D1 dot items? If it's a func method, right? I have to add bracket. Now when you print I, okay, you get each of these values in, okay, separately. So it's like it is same as iterating through a list. When you say for loop in a list, each member will be printed in different line. So each member of the list is printed in different line. Okay. If I want to know what is the member, so of course, you have various other methods, but if you want to know, okay, see, I want to know the value at index 2, right? Or key 2. So I can simply say print D1 of 2, right? If I say D1 of 2, I'll get this, right? But long process. If you want to write, let's see if this is not there. You can say for I in D1 dot keys, because I have keys, and I will, okay, I will, or not in keys, right? Items. Okay, so I in items, that means I will have two values. I have 0 and I have 1. So I can say if I of 0, that is key, equal to 2, then print I of 1. No, I mean, this is not the right way to do, right? This is the right way to do, but just to demonstrate how you can iterate through items and do your work, right? So if I say I have 0 because I will have two components, right? 0 is this, 1 is this. 0 is this, 1 is this. So I'm checking if I have 0 equal to 2, then you print I of 1. Okay. So this should print hello. Right? So this is how you can iterate through the list of dictionaries. Okay. So copy works exactly like the way it works in list. This is also mutable, so you can change the value. You can say D1 of 2 equal to something else, and it will get effect. It can get changed in the main dictionary. You can say D2 equal to D1 and D3 equal to D1 dot copy. What is the difference between these two? What is the difference between these two?
One is deep copy and one is shallow copy.
Which one is deep copy? Which is shallow copy?
Uh,
What is
the like D3 equal to D1 is this deep copy, like it
correct?
deep copy.
Right,
And copy is like shallow copy.
right. So what is difference?
Uh, it replace like D2 equal to D1, like same list will be copied into D2.
Yeah,
And compared to D3, updated values can't be copied, only like.
points to each other. No new copy
Mm.
created.
Yes, but copy new values cannot be copied. Like if any
Okay,
modification
this
is
is
there, it
like
cannot.
photocopy.
Yes.
At this point, they are copy, right? After that, there's no connection between them. So if I
Yes.
say D1 dot update 99, so your D1 will have 99. You can directly do here also, right? Update. This is a dictionary. So instead of doing this as T2, right? I can directly copy this here, right? So print D1, of course, D1 will have new value. D2 will also have new value, but D3 will not have this new value, right? Same concept that we did in list. Because D1, okay, so we add 99, which is fine, but see, the second D2 also has 99, right? Because they point to the same value. So there's one single copy in the memory, okay, and both are pointing to the same location in the memory. And then you have D3, which is copy at that moment. After that, they're different, like photocopy. You take a Xerox. After that, whatever changes you make to the original will not get reflected on the photocopy, right? So you create the copy at that moment. Okay. So what else? We have we have to. So we saw how to update, right? If you want to remove something. Now you have two options to remove. One is called pop, other is called pop item. Pop item is to remove the last added value. Since it's unordered, right? It look at the last add. What was the last added? 99. So if I say d1 dot pop item, see pop and pop, there are two methods. Pop takes k. Okay, which value you want to remove? Okay, in fact, it is the key, not the value. Okay, k is the key. So which key you want to remove? But your pop item doesn't take anything. You see, it does not need anything because it knows that I need to remove the last item. So if I print D1 now, okay, the last item will be removed, which is 99 is gone. Okay, so last added. Okay, last added. And if you say pop, you can say D1 dot pop key. So I want to remove true. So I'll say true. And when you run it, true is also gone. Right? So this is how you can do that. If you want the key, you know the value, but you don't know the key, right? So you have get option. So directly, if you do indexing, you pass the key and you get the value. But to get the key of the given value is given, you don't know the key. So you say print d1 dot get, and you give the value here. Value is, let's say, hello. Okay, and it will give you, okay, so it is not returning anything. So what I'll do is I will say this equal to a
So you
equal
want to
to,
assign some.
right, a equal to, and then I'm going to print a here. None. Hello is not there. Hello is there, right?
Yeah, it's there. Hello, it's there.
Okay, let me print d1 here. D1, yeah, it has hello. Or let me say 99. Or let me say 2. Oh, sorry. Okay. It is, sorry. So my mistake here. It is you have to pass the key here. Sorry. Okay. Not the value. So it is taking key and giving you the value. So to get the value when key is given. Okay. No, not the reverse way. Okay. The same as using square bracket. Okay. So here, if you do not find, it will give you. Okay. So advantage of using this over this is, now if I try to print d1 of, let's say, something which is not there. Okay, so it gives you error. Okay, your program stops. Okay, so when you are very sure, right, when you are running loops, okay, so when I say d1 dot keys and in a for loop, I'm only going to get valid keys, so I can use bracket indexing like that. But when you are trying to find, I'm trying to find, okay, and I don't know if it is there or not, then it is better to use get, because get will not give you error if value is not there. If value is not there, it will give you none. So when you get none, you know that you get none. That means you know that value is not there. Unlike indexing, okay, this will give you error. So when you are not sure, then you use get. Okay, if you are sure, okay, that value is there, like using in for loop kind of thing, okay, then we can give index. Okay. And you have clear, which is there in list also. if you say d1 dot clear, it's going to remove everything. So if you print d1, all the values gone. You'll have empty dictionary. Okay. So let's take an example. Okay. I'm going to move this away to back up to it. So let's say I want to add um, marks based on the roll number, right? Okay, so let's do that. So I have master data. Okay, we'll have all the data here, and while true, right? While true, because we want to get the number of for many students, right? And first we will read as roll number, right? So I'll create roll number equal to input, assuming that roll number is string. Even if it is number, that doesn't matter because we are not going to use it we are not going to use roll number for mathematical operation, right? If you're not using for mathematical operation, it doesn't matter whether it is string or integer, right? So input, enter the roll number, right? And then, okay, you can have a tracker. So student equal to 0. And every time you enter into this, you'll say student plus equal to 1. And I'm going to say enter the roll number for, okay, for student, okay, int of, not int, str of student, right? So this will be 1 plus, right? Enter roll number for student, and it is 1 colon, okay, so yes. And now marks in, let's say, 3 subjects. Okay, we'll make it simple. So I'm going to say for I in range 3, correct? And here you can say m equal to int of input, enter marks for student, okay, 1, enter marks for student 1 and subject 1. Student 1 or marks 1 for subject 1, something like that you can say. Enter marks for subject 1 of student 1 or for subject. Okay, for subject, okay, str of I plus 1. Okay, for student 1, right? Okay, you can run it and see. And then to find sum, you can say sum equal to 0. And here we'll say sum plus equal to 0. Right? So you get some, but I want to save the marks also, right? So to save the marks, I'll create a list here, right? List, and then I'll keep adding the data here. So list dot append, and you add you add marks. So end of this, okay, end of this for loop, you have roll number and list of marks. Now we need to create a temp dictionary, right? So equal to dictionary, and key is your roll, colon, and list is your value, right? And generally it's better not to use keywords, okay? Because if you have to convert list, it will not get converted. You're overriding. You're changing the meaning. So it's better to not to use inbuilt keywords. So, okay. So this temporary list is created. Now I'll append it to my master list, right? You don't have to create a temporary list. You can directly say, role dot list here. Update role dot list. Okay. Entire thing. Okay. This is how the dictionary will be created. So you don't have to create temp also. Okay. So this is done. Now you'll ask the user.
Here,
Okay.
the software if you written sum plus equal to 0.
It's M,
Sum
right?
plus
Anyway.
equal to m, right?
Correct. Sorry. Yeah. Anyway, my intention was not to print some. So correct. You're right. Okay. So, okay, you're right. It should be M, right? You're adding M to the sum. Okay. So master.update. So master.update is done. Now I'm going to ask the user, right? CH equal to input hit, hit enter to continue, else to stop. Okay. So if you hit enter, that CH becomes false. So if not CH, then break. No, if CH, right? If CH is true, then break. Simple. Okay. So now let's run this and see if what we are doing is correct or not. Enter roll number of student 1. I say 1001. Okay, the marks for subject 1 for student 1. Okay, 54. Okay. 56. Okay, 79. Hit enter to continue, else to stop. I want to continue. So hit enter. Enter the roll for student 2, 1002. Okay, marks for subject 1, student 2, 78, 67, 90. Let me do one more student and we'll stop. Okay, so roll number 1003. Okay, marks 90, 67, 89. And we'll stop here. So no, hit enter. Oops, what happened? We did not print, right? So outside you can print, right? All data. Okay. And then you can say master data. Okay. Let's run it. Okay. So roll number 1, marks 5, 6, 7. Roll number 2, marks 6. Okay, fine. So I put here this one. So what happened here? Okay, I said list, right? It should be list 1, right? It's list 1, right? So yes. So now roll number 1 is 1. Okay. 5, 5, 5. Roll number, okay, hit enter. Roll number 2, 7, 8, 8. Now we'll stop here. So now you see, you created a list. So you got a list where key is a string and values are in a list, right? So you read the data. Now you can operate different method on it. I want to see the highest, lowest, right? Same example like last time we did. You can find highest, and then you can find the roll number. Okay, who has the highest? So you don't have to create a different list to store roll number or the name. You have the roll number or name here itself. Yeah. Okay. So this is how dictionary we work. Any question? Okay. No question. We'll stop here. We still have 5-10 minutes, right? So let's continue talking about next topic called list. Sorry, not list. List we have already done. Set. Okay. Yes, no. Any question? Set is also similar to list and tuple. Only difference is it is unordered. Okay. It is mutable. Why did I say? Okay, I probably copied from tuple. So it is unordered mutable collection. Mutable means you'll have a lot of methods, obviously, right? And unordered means, okay, it does not even have key. What it says is I don't care the order. Okay. Now, example I'll give you. If I ask you to name 5 animals, okay, question is name 5 animals. Okay, you said lion, tiger, elephant, okay, uh, deer, and what else? Let's say panther. So these are 5 animals, right? Now another person says panther, deer, elephant, tiger, lion. Are the same or different?
Same.
Isn't it? So if you use list, tuple, or for that matter, if you use dictionary also, you can say 1, 2, 3, 4, 5. Okay, then you can't implement this kind of logic. Okay, where it doesn't matter the order. What matters are the values. Correct? The situation where and the set that you would have done in mathematics is exactly for that purpose. Okay, set means that I only care about the values. I don't care about the list. Right? Just because line is in number 1 position and somewhere line is 5th position doesn't mean they are different. They are same, exactly same. We are interested in the values, not in the order in which they are saying. Right? So if I tell you list 5 this, 5 that, you know, listing means it can be in any order. Okay. Okay. It doesn't matter which order they give. It doesn't matter that, you give. Yes. If you say list them in alphabetical order, okay, then maybe, one could be right, other could be wrong. But question is just list values. Okay. Now, another answer is if another student says 1 lion, 2 lion, 3 lion, 4 lion, 5 fifth lion. So will you give marks? Because he has written 5 animals, right? All lions. Will you give 5 marks? Or is it correct? Is it correct?
No.
Use your logic. Yes. It's okay. It's not correct, right? Because this is not, it just means that, it doesn't mean that if you repeat line 5 times, it becomes 5 animals, right?
Yeah, the same animal is repeating.
Correct. So in this case, again, you can't use list or tuple, right? Or even dictionary, okay? Because list dictionary, you can add duplicate values and it will assign its own index. So such situations, we use set. What set says is duplicate not allowed. It is only to represent value. So if you're giving me 5 even 100 times, 5 to represent 5, I just need 1 point. Okay, so in mathematics, what we do is, just give me a second. So in mathematics, what we do is, we create a set like this. We create sets like this, right? Oval, right? And then you say, okay, so this is representing 5 animals. Okay, now does it matter whether you put lion here or a deer here or panther here, right? These are your 5 animals. This could be 5 fruits. Okay, this could be 5 cities. So 5 cities is different than 5 fruits. 5 fruits is different than 5 animals. And you can represent anywhere. Okay, it doesn't say that no, one has to be up, 2 has to be down, anywhere. Right? It does not accept duplicate values. If you enter duplicate, it will remove duplicate and have only one value, right? If this dot represents apple, right? So whether you say, 1 apple or 5 apple, this dot is only 1 dot for all kinds of apple, right? This dot is for orange, so this dot will represent all the oranges. Okay? So this is the logic behind using set theory. Okay? Now, if I say union means two student. I asked two student to name 5 animals. Okay, I asked two students name 5 animals. So, okay, let's go back to our program. So this is the answer given by first student. Okay, PDETL. Okay, panther, deer, elephant, tiger, and lion. Second student, okay, has given PDE. After that, it has said jaguar, right? And let's say camel. So total, how many elephants I have now? For so what else as a teacher? Let's say I'm teacher of class 1, okay, and you have these as animals. So what will I say? Okay, in total, how many animals were named in the class? In total, how many were named?
8.
8? Is it 8? 3 common, correct? 4, 5, 6, 7. Only 7, no? Right? So
Okay.
in total, 7 animals were named. Now each student said 5, 5, 5, 5. But
Okay.
only 7 animals were named. Doesn't mean that if you have 10 students, is saying 5, you get 50 names. Doesn't work like that, isn't it? You got only 7 names. This is called union. Union operation is adding all together, and obviously
So the
set.
names are common.
Yeah, that is the property of set, no? Okay.
Yes.
Property of set
Sets. Yeah.
itself is removing duplicate, common. So in total, okay, you add them together. You don't say 10 into 550, but you say only unique values. So you say only 7 animals were named. Even though 10 students said 5 animals each, but only 7 animals were named. This is called union. Now, how many animals were common between student 1 and 2?
3.
Common between student 1 and 2. Yes. Okay.
3.
So, yes. So you have 3 animals common here. So this is called intersection. Oops. Okay. This is called intersection. Okay. Now, third part is, okay, if you remove animals from student 1 as told by student 2. Can you guess? I'm asking remove the animals, okay, from S1 as told by S2. S2 told something. I want you to remove that from S1. So which are those animals? So what is
Jaguar,
left?
camel.
So what is left? What is left? So see, from where I'm asking what is left? From S1, right? So this is your S1, correct?
TL. That means, yeah.
TL, yes. I'm saying from S1, remove what S2 said. S2 said P, D, E, PD is gone. Jaguar, camel. You don't have Jaguar, camel. So you can't remove Jaguar, camel, right? So what is left is only TL, right? So 2. This is called minus. A minus B, or okay, obviously A minus B is different than B minus A. So if I say B minus A or S2 minus S1, okay, minus S1 minus S2, right? Now if I say S2 minus S1, it means remove animals from S2 as told by S1, right? So remove from S2. So from this I have to remove it. Which all I have to remove it told by S1. So PD is gone. So here also you have 2, but you have Jaguar and Camel. Unlike here, you'll have Tiger and Lion. Correct? So these are the 3 main, okay, operations that we perform on set. Minus, okay, intersection, union. You can have, yeah, you can also have symmetric. So okay, so this is S1 minus S2. So similarly, 2, and these are your lion and tiger, correct? Now,
Yes.
S2 minus S1 is going to be Jaguar and Camel. Correct? So we have something called a symmetric difference. Symmetric minus symmetric difference. Symmetric difference means perform both S1 and S2 and give the common value. So symmetric difference is going to be L comma T comma J comma
JC.
C. Okay.
Okay.
So it's called
Not
symmetric difference.
common values.
No, whatever is left from both. So you perform S1 minus S2, S2 minus S1
Yeah,
and
yeah.
get the values. Okay. So it is like union minus intersection. Okay, that is symmetric difference.
Mm.
So you perform union, you add all together and remove the common element. So you are left with only this. Okay. So this is called a symmetric difference. Okay. So tomorrow we will write program to see how to calculate all this using set. Okay. Any questions before we stop? All good so far? Okay.
Yes, it's
Perfect. Then we'll see you tomorrow. We'll continue with our set discussion. Take care, everyone. Bye.